Hi there, you got Zach Henson, IO519. Tootsie's out running around. I'm a little bit upset with her right now because the last four recordings I did, she found it compelled to bark. And I think it would be very disrespectful if she's barking while I'm in the middle of the video. So you won't see her straight away. She may show up a little later on. Chi-square test. Chi-square, and I'm starting to really get into understanding the essence of language and description and how if you associate the meaningful labels, it's like any other language. Once you learn the language, the concepts become far more simple or simpler. And chi-square is no different. It's determining if a relationship exists between two categorical variables and then quantify that relationship between the two. You want to find a significant difference between those two variables and measure it. It's as simple as that. That's the essence of chi-square test, and we're going to run some on fields as cats on SPSS during this exercise. Then you have Fisher's exact test model that takes chi-square test to a higher level. And the accuracy when sample sizes are relatively small and the sampling distribution of the test statistic is too deviant uh, for a chi-square distribution to be of any use, then you use the Fisher's exact test model. And this test is normally used on 2x2 tables because it gives a more exact test, just as the name describes. We also rely on assumptions of categorical data. And there are two assumptions when analyzing categorical data, that they are independence and expected frequencies. So independence for the chi-square test to be meaningful, each person, either the item or the entity or whatever it is that you're studying, it contributes to only one cell of the table. Okay, and then you have the expected frequency, which is generally done with a 2x2 analysis, and it has contingency 2x2 contingency tables. No expected values should be below 5. If this test is broken, there's a radical reduction in test power. So the next thing we're going to talk about is odds ratio. Again, we're going to go through all this in SPSS with the cats that will be running shortly, but I wanted to get the audio portion of my descriptions in so that they could be meaningful as I walk through them to repeat myself. So the odds ratio it's used all the time. For two football teams, we did, I believe, our lab. I've already done my lab, and we compared Sage with Sussex and came out with the Sussex players are far better football players than Sage by a odds ratio of 3-1, or that would be the outcome of the odds. So you measure the effect size of the categorical data, and then you put the numerator over the denominator and comparing the two groups to come up with a percentage, and then you compare that percentage with each other when you have two teams, for instance, or two categorical variables that you're running this comparison on. And then you get an odds ratio. Then we go to phi and Kramer's V. Kramer's V are measures of strength of association between two categorical variables. Phi is used when 2x2 categorical variables and each variable has two categories. Kramer's is used when one of the variables So the measures of strength of association between the two categorical variables are Cramer's V. Phi is used with the two categorical variables, and each variable has two categories. Cramer's V is used when one of the variables has more than two categories, and that's the difference between the two. So now it's time for the fun. We're going to jump into SPSS, and I'm excited. I have downloaded the data from Canvas, and we are going to do the dancing cats. And so the first thing we're going to do is go to our data view and variable view. There we have it. We're going to enter analyze, and our drop down screen is going to be descriptive statistics, and we're going to go to the cross tabs, and here we're going to enter the type of training in our rows, and did they dance will be entered into our columns. So the second thing we're going to do in preparing for our run is we're going to click on chi-square, contingency coefficient, phi, and Cramer's V, lambda, and continue. The next entry will be cells, crosstab cells, and as you can see, observed, expected, rows, columns, round cell counts. I'm saving time so that I know your time is valuable, so I won't bore you with doing it. So I'll continue to click on. And as you can see, the next item here is exact tests. We want to do exact time per test of 5 minutes. And here we go. We're going to run continue and OK. And there we go. Yahoo! Exciting. Here's our cross tabs output. So in observing our SPSS output, the first thing we look at is the case processing summary, which is the type of training and did the cats dance and how many participated. So our N is 100% valid. We had no cats missing, so we had complete participation. So now we're going to go to our cross tabulation table and observe the outcome or the output. Type of training, did they dance? So when observe the type of training food as a reward of the cats that did dance, there was 28 that danced, and there's 10 that did not dance. Our expected count was 14 that would dance and 23 that would not dance as food as a reward. Affection as a reward, 114 did not dance, 48 did dance. Our expected count was 100 would not dance, and 61.6, I don't know how they got 0.6 of a cat to dance, but that's what we expected, or 62, I'm sure. Cats were going to dance, or expected them to dance as a result of affection. And so that's the output. So as I review the output variables, if using food as a reward to get a cat to dance, our expected was 23 that wouldn't. However, only 10 didn't. Our expected 14 were expected to dance for food as a result. However, we got twice that amount, or we got 28 to dance. So, correspondingly, when we have affection as a reward, we expected 100 to not dance, when in fact 114 didn't dance. And we expected that 61 would dance, however, only 48 did dance. So, conclusively, that food as a reward is a much higher motivator to achieve the desired outcome than affection, according to the results of our chi-squared test, as we can see by the numbers. So first, let's check that the expected frequencies assumption has been met. So we look at, on the contingency table, we look at our, first of all, the smallest expected count. And as long as the value of the smallest accepted count exceeds 5, the assumption has been met. And as we can clearly see here, that within the expected count, the number is greater than 5. So we can, because the value exceeds 5, the assumption